This is actually a really great question. Can someone explain this to me? I'm seeing a lot of this. This went around. It went around on the internet, and people were saying like JavaScript moment and all this, and they were laughing about it, and people were all this. This right here is just a fundamental misunderstanding of values or of how things are specified. So let's just talk about that really quickly. Get out of this thing. Go right here and go into Node. And this is what we're going to do. So if you go like this, 017, notice that it prints out the value 15. That's because 017 is short for 0 octal 17, meaning a base of 8. That means 0 octal 18, well, that can't exist, right? That's not a real thing. But 018 gets converted into a decimal if it's 8 or higher. So if you don't know what octal is 0, 1, 2, 3, 4, 5, 6, 7. That's octal, 8. It only has 8 symbols in counting. So 018 is valid decimal or valid base 10, but it's not valid octal. So it gets converted. This is cursed behavior. This should have always been, this was a horrible hack for octal. 0 has always been a horrible hack for octal. 0 was always a great octal thing. So that means when you do something like 017 and convert this to a number, it converts it properly, usually to decimal. Or it should be octal. I don't know why that one didn't do it. What is this one? I thought that one, oh, is it number that does it? 017, let's go like this. Is it number that's the cast? What's the cast that it does? 018 equals 018. There you go. I think it tries to convert it to octal. It can't do it to octal. If you do this, it can convert it successfully. Oh, that one doesn't do it either. Oh, that's because I did triple equals? Double equals. There we go. So this makes sense right here. This one can't be converted. Therefore, it's 18. Therefore, this one also gets converted, and it's 18. This one doesn't do an octal transformation when you do that. So leading zeros apparently don't do octal. I didn't know that. I knew it was one way. This one does go to octal, which is 15. This one gets transferred into a number, which is 17. So does 15 equal 17? No, it doesn't. There you go. It's just simple type coercion and non-similar translations. That's super confusing. Well, yeah, that's why you should never use leading zero to denote octal. And also, octal is only really useful in file permissions. And so if you ever do octal, just say 0, like that. Right? So if I did 0,017, I believe this should, there you go. So if I went like this, 017 equals 0,017, it'd be correct. Because it now knows to denote it into octal. There you go. Try the bun REPL. It's going to be the exact same thing. Good old octal. Yeah. So be careful about octal. TypeScript, it's not a TypeScript problem. This is every language. You can do this in C. If C had a operator to implicitly typecast, then this would work. If C had an operator to implicitly typecast, it would do it. But it doesn't. The reason why I wanted to cover it is because it's not a JavaScript moment. You could create this with anything. If you parse out an int, you are likely to be able to create it in almost any language. Can DHH fix this? Absolutely. It's a skill issue. This is actually a skill issue. This isn't some JavaScript is hilarious issue. So meme is faulty. Meme is unfortunately faulty, and I hope you learned something. Hopefully everybody here today learned something that's amazing. This was our little let's talk about it technically kind of moment. Now I'm curious. Here. Okay, since we're already here, let's go like this. Vim APM. We're already here. Let's go into here and let's go like this. Let's go into, what do I have in here? What do I got in here? Okay, let's go into here, and instead of all this, let's jump in here and go test. Let's just call it test because I think test is not one. Main.go. We'll just go really quickly. Package main. There we go. Func main. Let's put in there, and let's go like this. Let's see. A equals 017. B equals, let's see, strings. All right. Oh, no, it's stir convert, right? Stir convert. Let's see, parse int 017. Oh, see, this one, there you go. You already have a base, right? So you actually literally can't run into this in Go. Is there an A to I? Do they have A to I? They do have A to I. So this one you possibly could. Let's find out. Right? Yeah, there we go. Put that in there. Log fatal. There you go. There you go. And then go like this. Format, or we can use log since we already have it. Log, let's see, print ln, bam, bam. A is equal to B, else. There we go. And do that. Go run command test. Whoopsies. A and B are not equal. There you go. Recreated it. Recreated it in Go. Yeah, it's going to be 15 and 17. Yeah, it's not a big deal. Like, it's not a big deal. It's not a Go moment. Again, this is called computer numbers moment, okay? Computer numbers moment. Stop being such a dummy, okay? Go fake. Fake, fake, fake. There you go. See? There you go. TS fixes this. There you go. Skill issue. Yeah. That's why parse int is a little bit nicer, because parse int forces you to say the base. And by forcing you to say the base, you're not going to make this mistake, right? This is why bases are very good. A2i assumes base 10. Well, there you go. Yeah, and the more you know. The more you know. It's easy to mess this up. It's easy. Honestly, it's very easy.